Well, I studied engineering science at Oxford University, and then I worked on various projects, a dam project in North Wales, a rail redevelopment project in London, and then I went out to Malaya and worked on a power station construction. And then I was asked to go to Hong Kong by my partners to take charge of the design of the Hong Kong Mass Transit Railway. I had managed to develop myself with a reputation of managing multidisciplinary contracts and pulling design teams together, and I think that was probably why I was selected. I worked briefly on when I first arrived in Hong Kong, the cross-harbour tunnel was just about to open, and we had a bit of a crisis because the electrical contractor walked off the site in a huff and went back to Holland, and there was nobody left to test the machinery 5 days before the governor was due to open it. So a colleague and I spent the next 5 days testing all the electrical and mechanical equipment, and that went on all day and all night, and I think I went 3 nights without sleeping. And then on Friday everything was okay and the tunnel was opened, and I went out to dinner that night and fell asleep in the soup. The Hong Kong Mass Transit further studies had been submitted to government. We could make no progress because John Calverthwaite, the then Financial Secretary, was against the project. And then in 1972 he retired, and Philip Haddon-Cave took over as Financial Secretary, and he was very enthusiastic, and then we were commissioned to start the detailed design. Then after we'd been going a few months, the Hong Kong government decided they would try and find a consortium, an international consortium, to build the railway for a fixed sum of money, and the sum of money was set at $5,000 million. And we managed to get the first contracts out in 1975, and that's when the work started. Well, there were quite a lot of challenges which were really quite new. The first one was that the expected loading of the Hong Kong stations and tunnels was going to be far heavier than any other system that had ever been built. And there was the problem of dealing with the temperatures in the tunnels and stations in the Hong Kong summer, requiring some quite serious consideration to ventilation matters, and the trains, of course, were going to be air-conditioned. But to a certain extent we got round that by persuading the government to persuade Hong Kong Electric and China Light and Power both to supply the first line, so that we could, if we lost one supplier, we could quickly switch to the other one. And as a result of that, I don't think there has ever been a case of a stopped train in a tunnel in Hong Kong. But that was a worry to us. And the ventilation, of course, required very large ventilation shafts at both ends of all the stations. And the tunnels had to have impulse fans to blow air down the tunnels to try and clear the hot air out. So that was a second problem. A third problem was a very complicated junction at Mong Kok, because for the modified initial system there was no Chun Wan line, so the trains had to run straight from Kwun Tong through to Central. But once the Chun Wan line had opened, then the trains from Kwun Tong would stop at Waterloo, and passengers who wanted to go to Chun Wan would have to walk across the platform to get a train from Central to Chun Wan. And of course all three might want to go in either of other two directions. So we wanted to achieve all these interchanges by just going across the platform, not going up an escalator. So this interchange was eventually arranged between 3 stations, Prince Edward, Argyle and Waterloo. I think some of the stations may have now changed their names, but that's what they were when we started. It was a very complicated arrangement of tunnels in Mong Kok, and we had a job to get them in. Another problem that we faced was in Nathan Road also. We didn't know where any of the utilities were. We didn't know where the gas pipes were. We didn't know where the electricity cables were. We didn't know where the water pipes were. And the reason for that was that the Japanese had destroyed all the records while in their occupation during the war. So we had to employ a chap to spend his whole time, whenever there was a road opening, to go out and measure where they were. And by the time we started construction, we pretty much knew where all the utilities were. Another problem that we faced was the question of tickets. The volume of passengers was so high that if we had cardboard tickets, there would be so many millions of tickets used each day that it became a bit of a headache. And we were the first system to introduce plastic reusable tickets. And these tickets would run for between 30 and 35 trips before they had to be replaced. with the very high loading in Hong Kong, we had long decided that we needed unusually wide trains. We required our trains to be 3.4 metres wide. The Japanese consortium were offering us trains 2.8 metres wide, so we were very glad that that didn't come off. So with the 3.4 metre wide trains, and we also required passengers to move down the train as easily as possible, so we insisted that the vestibules between the trains would not protrude on the passenger, so that it was just one long clear line straight down the train, and to this day you can still see the train weaving in front of you as you go in, and I think that worked out very well. I must tell you about the much maligned stainless steel seats on the mass transit railway, and I'll tell you how that came about. We had originally planned to have the trains fitted with dished fiberglass seats, and the contract was let on that basis, for the trains was let on that basis. And then the fire service suddenly discovered this and said, if you insist on having fiberglass seats, we will not allow the system to open for public use. And the fire services had the power to do that. And their reason was that if there was a fire on the train, the toxic fumes would start killing people. So we clearly had to do something about that. We thought about using mild steel, which we could still dish, but mild steel would need painting, it would need maintenance. So in the end, we had to make a quick decision, and we decided to settle for stainless steel seats, which you can't dish because if you try dishing them, they crack. So that's how we got our slidey stainless steel seats. I think that the biggest changes for me in the time I was in Hong Kong, apart from the continuing building of high-rise buildings, was the improvement in transport infrastructure. When I first went to Hong Kong, if we wanted to go to the airport in a car, you had to go on the car ferry to Yau Ma Tei. When the cross-harbour tunnel opened and the first line of the mass transit opened, then the whole business of getting around Hong Kong was hugely easier. Well, I think what has contributed to the success of Hong Kong is that it has been right from the start exceedingly well run, well operated and well maintained. And I think that they've kept up the high standards of passenger movement, passenger signage, and the cleanliness of the trains and punctuality. And I just think it's been very well run. Well, I mean, I think obviously I'm bound to say that I think the design was very good in the first place. But quite apart from that, I think that right from the word start, it's been very well run, very well planned. The signage has been good, passenger movement has been well thought out, and all the extensions have been done since I left. And they've now introduced computerised routine maintenance, which is a great step forward, and which they're now exporting to other systems. There was one other thing I was going to say about why I think Hong Kong was successful. The Bay Area Rapid Transit System in San Francisco, which I went several trips to look at in detail, it had a great passenger appeal, but it was technically a disaster. They tried to introduce every new device they could think of. They tried to have some sort of computerised system going on the last bit across the harbour to the central part. And they wanted to run trains through there every 2 minutes. It was 10 years before they got it below 6 minutes. They got an aerospace company to build the trains. They'd never built a train before. And the trains couldn't run after 6 o'clock in the evening for several years. Because they had to spend so much time in the workshops. Well, we couldn't have that in Hong Kong. So we stipulated that we would not accept any tenders which involved components that hadn't had at least 5 years proven practice and service. Because the Hong Kong trains had to run from 6 o'clock in the morning to 1 o'clock the following morning, 365 days a year from day one. And that happened. We achieved that. So I think that's got to be a contributory factor to the very early success of the initial system. Running trains at 2-minute intervals in the peak period right from day one. And of course we had to have automatic train drive. You couldn't do it with the driver, because the driver would slow down by the platform and then creep down the platform. So in Hong Kong you had an automatic train drive. We were one of the first people that had it. Automatic train drive, and all the driver had to do was to press a button to close the doors. He had to do nothing else until he had to close the doors at the next station. And that way we were able to introduce a 2-minute headway, and occasionally in the peak time we could run it down to 1.5 minutes. And that was then the fastest. And considering the size of our train, that was quite an achievement.